All right, this is day one of the distance learning packet, and this is math. I'm not sure what page this is, but it's the first task in the math section. So this is 8th grade functions, and the task is battery life. So you can read this, and you can pause the video if you need to take time to go over some things. But basically it says that he has two devices. He has a tablet, and he knows how quickly it charges, and he's also got a new phone, but he doesn't know exactly how quickly it charges. But he plotted some percentages in this table. He has the time he plugged it in and the battery percent, and then he wrote it down every 10 minutes. So you can see that in the table. And then the first part is asking what percentage of the battery will be charged, or what percentage of the battery will be charged for each of the two devices when they leave. Okay, so when do they leave? How many minutes are they going to leave? So it says an hour before they leave, he starts all of this. So we have two devices. So we have a tablet and a phone. Okay, so the tablet, he knows charges 12% every 15 minutes, and it's at 40% right now. So let's just make a table. Let's do X because we have time, and time is always X, and then percent will be Y. So we have the minutes and we have percent. So at 0 minutes, it starts off at 40%. And then it says each 15 minutes, so another 15 minutes, it adds 12% more. So we have 52%. Okay, so that's our pattern. And in hours, so that would be 60 minutes. So there we have an hour. So you just keep following the same pattern. So every 15 minutes, it adds 12%. Okay, so 52 plus 12, we have 64, 76, and 88. Now, just like in class, check my math, make sure I'm not making a mistake. I mean, I am just human. You have calculators, you have your phone, you can check all this out. So for the tablet, it is going to have 88%. Okay? And for the phone, we already have this table made, and it goes up to 30 minutes, right? So let's look at the pattern here. So every 10 minutes, it adds 12%. Okay, let's make sure that's right. So every 10, it adds 12. Every 10, it adds 12. So, okay, that's our pattern. So then let's just continue that same table, but let's not recreate what's already done. So the next points would be at 40, and then 50, and then 60 is what we're looking for. So at 40, we add another 12 to 56. So that would be 68. Okay, then we add another 12. So that would be 80, and then 92. So the phone will be at 92% when they leave. Okay, part B. How much time would Sam need to charge the battery 100% on both devices? Okay, so we can see that, it looks like one of them is charging quicker than the other one. So let's continue our table. Let's see if we can find exactly 100%. So on the tablet, if we keep adding 12, right? So if we add 12%, that would give us, what would that be, 90 and 10, so that's 100. That's perfect. So at 100%, and we have to continue the same pattern on the X side, which was every 15 minutes, right? This is for the tablet. So 60 plus 15 is 75 minutes. Okay, so that's fine. For the phone, let's see what happens here. So if we add another 12, then we get 104. But we want just 100%. We can't have 104%. So what can we do? Let's see if we can write an equation, right? And we can set y equal to 100, and we can solve for x. That would be a great way to do it. But let's see if we can work this table to help us. Let's see if we get a ratio. So this is y, this is x. Remember, slope is the change in y, which is 12, over the change in x, which is 10. So if we simplify this, we get 6 over 5. Okay, so 6% every 5 minutes. So if we add 6%, I'm going to get rid of this. So if we add 6%, then we add 5 on the other side. So that's 65 minutes, and it'd be at 98. So we're almost at 100%. Okay, so that's not quite there. So we want to add 2 more, okay? So if we add 2 more on this side, that's a third. Okay, so we're going to have to add, it's not going to come out to a whole number, we have to add a decimal. But let's read this question again. So it sounds like we're going to get into some pretty messy numbers. So usually when that happens, maybe we overread something, maybe we're overthinking. So it says, how much time would Sam need to charge the battery 100% on both devices? So we must charge for 75 minutes to get the tablet to 100%, right? So would 75 minutes be long enough to charge the phone? And yeah, just looking at our numbers here, we have 65, and we're going to add a small amount that's less than 5, and that would be definitely less than 75, and that would get it to 100%. So the answer would be Sam will need to charge both devices for 75 minutes, or you can say an hour and 15 minutes. Okay, so that takes care of the first page. All right, so the next page. So this is a rule 4. We've done these a lot in class, so I'm not going to go over everything. I'm just going to make sure that we can get our equation and then find slope and y-intercept. Okay, so we are given some information that meat cost $8 per pound at a store. So $8, remember, per pound is our clue for slope, or our rate. So $8 per pound. So our slope is 8. Okay, and then the y-intercept. So let's think about this. If we're buying 0 pounds, how much would it cost? It would cost $0. Okay, so this is a proportional relationship. It's going to, the line will go through the origin. Okay, and then the equation, remember, is y equals mx plus b. Okay, where m is the slope and then b is the y-intercept. So we substitute those in. We get y equals 8x and then plus 0, so we don't have to add that. So y equals 8x. So let's think about this in our heads. 2 pounds would cost double that, so that would be 16. So let's check our equation to see if it's correct. So if I substitute, so x is going to be the number of pounds. Okay, I'm just going to write that up here. So this is x and this is y. So this is the number of pounds, okay? And then this is the cost. Let me just write that out, cost. Okay, so x is the number of pounds. So I said 2 pounds. We substitute 2 in there, we get y equals $16. Okay, so that works. Okay, again, pause it, finish it, check your work, and you can leave a comment if you have a question. Okay, so the next page. Write an equation that models the linear relationship in the graph below, so that's number 1. Number 2, write an equation that models the table. Number 3, write an equation. So these are all equations. All right. And going back to the previous page, what do we need for an equation? We need slope and we need y-intercept. So let's see if we can figure that out for both of these. Okay, so the first one, so if we have a graph, we can easily find the y-intercept by looking at the point on the graph where the line crosses, which is this point here. So b is our y-intercept, so that would be 4 because it crosses at 4. And our slope is rise over run. Okay, so here's 2 points. We're going to go up and we're going to go over. So up, positive slope. Up how much? From 0 up to 4. So up 4 over, this is at 1, 2. Okay, so over 2. So 4 over 2, we simplify. 2 over 1, or just 2. Okay, so our equation for all of these is going to be y equals mx plus b. Okay, so substituting, we get y equals m, which is 2, x plus 4. And let's just check. We have 2 points. Let's see if it works. So we have 0, comma 4. All right, so that means when y is 4, x is 0. So let's see if both of those sides are equal. So we have 4 equals, and that's 0. 4 equals 4, that checks out. The other point, let's see if that works. So when it's x comma y, so we have 0 equals 2 times negative 2, which is our x value, plus 4. Okay, so 0 equals negative 4 plus 4. So that's 0 as well. 0 equals 0. So that works. Okay, moving on. When we have a table, remember we're just looking for that pattern. Change in y over change in x. So how is this side changing? The y side. It's adding 1. Okay, it's adding 1 each time. On the x side, we're adding 2. And we're adding 2. Okay, so slope is change in y over change in x. So change in y is 1. Change in x is 2. So our slope is 1/2. The y-intercept, okay, remember, that's when x has a 0. So we can work backwards to find that point. So if we keep working backwards, so our slope is for every 1 on the y side, we're going to move 2 on the x side. So instead of going, we could fill this in, go by 2. So 10, 8, 6, 4, 2. We could do that, okay? But there is a better way. So let's make an equivalent ratio that will move us a little quicker. So we want to go from 12 to 0. So I want a 12 on the bottom. Okay, so what would we have to do here? So times 6, right? So times 6 on the top. So that's 6 over 12. So if I go backwards 12, I have to go backwards 6. Okay, so 12 minus 12 is 0. So that's what we want. That's our 0. And then over here on the y side, we have 14 minus 6, which is 8. Okay, so b equals 8. All right, we put it all together. We get y equals m, which is 1/2 x plus 8. Okay, and just kind of mentally thinking about this. So if I substitute a 12 in here, if I put a 12 in for x, 12 times 1/2 is 6, right? 6 plus 8 is 14, and 14 is what we get. So it works. All right, last one. Write an equation again. We're going to do the same thing. So we're just looking at the rate of change or the slope. So on the y side, we're adding 1, adding 1. On the x side, we're adding 2, adding 2. Okay, slope is change in y over change in x. That equals 1 over 2. So that's the same as the other one. Are these exact same points? 16, 16, 16, 18. Bummer. I would have just used the same equation. All right, so let's do the same kind of strategy here. So we want to go back 16 so I can get to 0, because that's where I'm going to find my y-intercept. So we want an equivalent fraction that has a 16 on the bottom. Okay, so I get that by multiplying by 8. So we get 8 over 16. So I'm going to go back 8 on the y side. So 18 minus 8 is 10. So b equals 10. Okay, so that is y equals m, which is 1/2. And then we have an x, and then plus our y-intercept. And it's positive 10 or plus 10 because it's a positive number. We're not dealing with any negative numbers. All right. I believe this is the last one. Yep. Okay, so this is a proportion equation. Okay, I'm going to let you fill in the boxes here, but I just want to go through how we solve this equation. So a couple of things. We could use what we did in the previous page and look at equivalent fractions. Okay, so that would be like, for example, 3, and I wanted to have a 21 here, so 3 times 7 is 21. So if I multiply by 7 on the bottom, 9 times 7, okay, so we get 63. All right, so that's one way to do it. All right, some of you probably learned cross multiplication. So then we just multiply across. So that would be 3k equals, and then 9 times 21. Okay, so 21 times 9. All right, and then we just solve it for k. So let's see if we get the same answer. So we're hoping to get 63. Okay, so 3k equals 21 times 9. 1 times 9 is 9. 2 times 9 is 18. Okay, and then the last step, we divide both sides by 3. Okay, that's a 1, so that's just 1k, or k on the left, equals 189 divided by 3. So that's a 6, that's 18, that's perfect. 9, 3, no remainder. Okay, so we're done. So k equals 63. All right. So this one worked out nicely both ways. I think it was a little faster to think of equivalent fractions, but again, if you have a decimal, it's not always going to work out that nicely. So choose whichever one you like, and then fill in your boxes with the rest. All right, so that's it for day 1.